Hello, welcome all. You're welcome to Harik Dev channel on YouTube. Today we'll be discussing IP address. So we're going to be looking at various topics. We'll be looking at what an IP address is. We'll be looking at where it is used. We'll be looking at what the structure of the IP address is, and then converting an IP address from decimal to binary and from binary to decimal. I hope you have a nice time and I hope you learn as we move along this train. So what's an IP address? We can say that an IP address is actually a naming system which uniquely identifies computers and other devices on the network. So let's say you're on a network, or you are connecting via FlashShare, or you're connecting to the internet. It's a network because your computer is connecting to another computer in another specific location. So if you must connect with another computer in another specific location, your computer must have an IP address, whether it was handed to you by your internet service provider or it was handed to you or you statically assigned it maybe by a network engineer. There's always an IP address that allows a computer to be able to speak to another computer. So even if you're on your phone or your mobile phone, anything that connects to another computer or another device that uses the internet must always have an IP address for it to be able to connect with another device on the network. So let's look at a case scenario of two laptops or two PCs, PC A and PC B. The case scenario is that Harry is the IP address of PC A and Stephen is the IP address of PC B. So if PC A wants to send a message to PC B, it's going to put on the address note Stephen as the address of PC B. And if PC B wants to send an IP address, so send a message to Harry, it sends it to Harry, address to it. If PC B wants to send a message to PC A, it sends its address to Harry. Just like you have your postal addresses. Once you want to send a mail, you have to put an address where your mail is going to be addressed to, and then the postal people will take care of how it gets there. So once PC A wants to speak with PC B, it just gives the address as Harry, and then the network determines how best to get to PC A. So we're looking at the standards and the notations. There are two various standards of IP address. There's the IPv4 standard and there's the IPv6 standard. We won't be going much into the IPv6 standard in this lesson. We'll only be considering the IPv4 standard. So what's the IPv4 standard? First of all, is 32 bits in size, and a bit is a binary number, which is a binary digit, which is either a 1 or a 0. So an IPv4 address is 32 bits in size, and it consists of 4 numbers between 0 and 255. Those 4 numbers, you can call them octets. It consists of 4 octets, which the numbers vary from 0 to 255. And computers work with the binary form of the 4 groups. So if you have a number from 0 to 255, 4 different places, that's 4 different octets, the computers work in binary with it. Human beings actually convert to decimal for them to actually be able to read it. Like what I have here, the example I have here, 172.168.25.14 or 255.158.247.0. The computer converts this to binary for it to be able to interpret it and use it well. So let's look at the binary form of an IP address. So we have 4 octets, as you can see here: octet 1, octet 2, octet 3, and octet 4. And this is the representation of this decimal number we saw before in binary. Here we have it. It's 8 bits number. If you calculate the 8 bits plus 8 bits plus another 8 bits plus another 8 bits, it gives us 2 bits, which make up an IPv4 address. So here we have 111110000.0001111. This is the binary representation of an IP address. If actually what the computer says is what it converts to, and this is what it uses to be able to give an IP address meaning, because computer only understands binary or hexadecimal. So let's look at conversion of a binary to a decimal. So where we have a binary of 8 bits, 111000101. So we want to convert it to decimal. Here we have each representation is a 1 or a 0. So here we have 1, we're converting it to decimal. So we have a 1 times 2 raised to the power 7 plus a 1 times 2 raised to the power 6. Because of there's a 1 here at the first entrance and a 1 also here. So anywhere that is a 0, it will be 0 times 2 raised to power 4 plus a 0 times 2 raised to power 3, then plus a 1 times 3 raised to power 2 plus a 0 times 3 raised to power 1. So after everything, the computation is where is there a 1, we times it by a 1. Where is there a 0, we times it by a 0, the decimal equivalent, because this go in the ratio of 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have 128 plus 64 plus 32 plus 0 plus 0 plus 4 plus 0 plus 1, which gives us 229. Same goes for here. We find that everywhere that is a 0 in the binary number, is always a 0 times the equivalent, 2 raised to power 7. And it's important for us to learn and understand that it starts from a 0, not from a 1. So we go from a 0 to a 1 to a 2 to a 3 to a 4 to a 5 to a 6 to a 7. So even though we have 8 numbers, because we are starting from 0, we have 7 of them. That means we have 0 to 7. So, and everyone that has a 0 as its binary digit, anyone that is a 0 as a bit, will be multiplied by a 0, thereby equating to a 0. So here we have 0 plus 0 plus 0 plus 16 plus 0 plus 4 plus 0 plus 1, which gives us 21. So I want to convert from decimal to binary. Let's take an example of 170 as a decimal digit. So we have 8 different columns of what each one means. 2 raised to power 0 is equals to 1, 2 raised to power 1 is equals to 2, 2 raised to power 2 is equals to 4, 2 raised to power 3 is equals to 8, 2 raised to power 4 is equals to 16, 2 raised to power 5 is equals to 32, 2 raised to power 6 is equals to 64, 2 raised to power 7 is equals to 128. So let's say we are looking at the number 170, we want to convert it to binary. First of all, we'll check if 170 is greater than or equals to the first column 128. If it's yes, then we'll put the value 1 in column 1 and then subtract 170 from 128. We subtract 170 from 128 so that we can be able to compute the remaining bits in the octet. So we have placed 1 in the first column. So now we go to the second column to compute. After subtracting in the previous column, we got a 42. So now, if we check now, see if 42 greater than or equals to 1 to or equals to 64. If no, we put 0 in column 2. So after putting 0 in column 2, we now check again. Is 42 greater than or equals to a 32? If yes, we put 1 in column 3 and subtract 42 from 32, which gives us a 10. So we put 1 in this column and then we'll put the 1 in the column. We now check if 10 is greater than or equals to 16, which is the next column, and we see that it is not. So we put 0 in column 4 and then we move to the next column. Then we now check if that same 10 is greater than or equals to 8. If yes, we put 1 in column 5 and then subtract 10 from 8. So 10 minus 8 gives us a 2 and we put 1 in column 5. So we have this. So now we check again our subtraction, as 10 minus 8 gives us 2. So check is 2 greater than or equals to 4, and we know that it's not equals to and it's not greater than. So we put 0 in column 6. Then we now check again, is 2 greater than or equals to 2? That's for column 7. Yes, so we put 1 in column 7. Then we subtract 2 from 2. Putting 1 in column 7, subtracting 2 from 2 will give us a 0. So we now check is 0 greater than or equals to 1. And so we know that 0 is not greater than, neither is it equals to 1. Therefore we put 0 in column 8. So at the end of the day, converting 170 to this binary form gives us a 101 01010. That's the binary form of it. I hope this tutorial was informative. If it was, like us, drop your comments below and try and subscribe. Thank you very much for viewing.